the Linux kernel. In this nugget, we're going to talk about customizing and compiling the Linux kernel for yourself. First, I'll give you an overview about the Linux kernel, and we'll talk about reasons why you might want to compile the kernel for yourself. Then we'll go through the basic steps of compiling the kernel and installing it, and finally I'll point you to a good resource where you can learn more about customizing your Linux kernel. Well, pull up a chair and let's get to work. All right, well, let's start talking about customizing and compiling the Linux kernel for ourselves. Now, before we get into the specific steps of what we're doing here, let's just talk a little bit about what it means to compile a program at all. All right, so the Linux kernel is written in the C programming language. All right, so the source code for Linux is in C. All right, now the source code is just written by people all over the place in the C programming language, and it will run on many different processors. It'll run on a Pentium 3, it'll run on an Alpha, it'll run on a Spark Station, all these different kinds of processors that are out there. But it's the same source code that will run on those different processors once it's compiled. So the compiler takes the source code and it turns it into machine language. And each processor, like a Pentium 3, has its own machine language, and the compiler knows that machine language and turns the source code into language that machine understands. So once you've compiled the source code on the Pentium 3 processor, then you've got some executable code, is what we call it, in the language of that processor, okay, so that the processor understands it. All right, so that's what it means to compile a program, is take it from source code to machine language. Now remember, from our discussion in the first part of the series, we talked about the Linux kernel and how nowadays the Linux kernel is what we call a modular kernel. So there's a base kernel, and that's sort of the heart of the Linux operating system. And then there are all of these modules that a system administrator can decide to plug into the base kernel. So maybe the system administrator wants support for this particular file system, or they want support for this device. Okay, so there's a device driver that's a module that they can plug into the Linux kernel to get some extra functionality out of the kernel. All right, so then all these other modules can be plugged in at some later date, but they're not eating up memory in the computer because they're not part of the kernel right now. All right, so this is not compiling the Linux kernel. Okay, this is just modifying the kernel via modules. All right, this is different. What we're going to do in this nugget is we're going to look at this base kernel and decide what gets compiled into that base kernel and which things are available as modules. Now you might be saying to yourself, isn't this risky? I mean, you're telling us that the kernel is the heart of the Linux operating system, and we're going to take that kernel and compile it to machine language. It seems like we could just mess everything up and not have a functioning system anymore. Well, it's not risky if you follow the way that we're going to do it in this nugget. What we're going to do is we're going to have an old kernel, okay, the functioning kernel in our system, and we're going to leave that alone. And then in a different directory tree in our machine here, what we're going to do is create the new customized kernel. So maybe we're updating the kernel to a new version. Maybe we're trying to add in certain hardware support. Maybe we're trying to streamline the kernel, whatever. Whatever we do to create this new kernel, we're going to do in a separate directory from the old kernel, and then we can compile it and do all that. And then once it's all set up, then we can restart our machine to boot into this new kernel. If we don't like what's going on, we don't have support for some particular device, or something's not working the way we thought it would, then we can reboot again, but boot back into the old kernel and mess around with the source code or the compilation steps to create the new kernel again. Then we can boot into the new kernel and so forth. So we'll always have a fallback that we know is completely functioning. So it's not really risky, but it's something that we have to undertake with a great amount of care. Now you might be asking yourself, why would I want to customize and compile the kernel for myself? Well, there's a few reasons I've listed here. One of them is if you're doing kernel development. Obviously, if you're changing the source code of the kernel to improve it or to tweak something, you're going to have to learn how to compile the kernel for yourself, because that's the only way you can test out the changes that you've made to the source code. But this is a very small percentage of the Linux community. It's not for the normal users who are not doing kernel development. Us normal users, we're doing things like adding new hardware to our system. So if the new hardware has a device driver in the form of a module, then we can just take that module and plug it into the base kernel, like I was saying on the previous slide. Okay, but if this new hardware is so brand spanking new that it doesn't even have a modular device driver yet, maybe it's got some experimental device driver that we then have to compile that experimental device driver right into the base kernel so that we can use this new piece of hardware. So this only happens with, like I said, brand spanking new pieces of hardware that are not supported yet with kernels that are supported. Remember, though, that if you're ever compiling some experimental device driver into your kernel, there are some dangers associated with that, and in the fact that it's an experimental device driver, and all the bugs might not have been worked out of that yet, so things might break or things might behave a little strangely. So always be aware when you're recompiling the kernel to add support for some brand new hardware. Poke around on the internet, look at the various forums and things like that, and see if people are having issues doing this, and if experts are having issues with adding some new piece of hardware, and you don't consider yourself an expert, you should probably take a step back and wait for things to sort themselves out before you try to add that new hardware to your system. Another reason that people customize and compile the Linux kernel for themselves is that they like to streamline the kernel. If you have a machine that's running in some ultra high performance application where you don't want anything in the kernel that isn't used, then what you can do is you can recompile the kernel and pull out a bunch of various little pieces. So you can get rid of little pieces of the kernel that you don't need and get them out of there, and then the kernel is more streamlined. Now this was a bigger deal back when Linux was a true monolithic kernel. When Linux was a monolithic kernel, it was this big honking thing, and every support that you wanted for the kernel, every piece of hardware, every file system that you wanted the kernel to support, you had to put into the kernel from the very beginning and compile it. Okay, so it was this big monolithic beast. All right, and it was very true back then that you could pull out a lot of things and streamline the kernel drastically. Nowadays that Linux is this modular kernel, well, it's kind of, the module support takes a little bit of extra space in the kernel, but it's much more streamlined by default nowadays than it was, 5 or 6 years ago when Linux was a monolithic kernel. All right, so like I said, though, if you're in some ultra high performance setting, you might compile the kernel for yourself to have, an ultra streamlined kernel that's very efficient. All right, another reason that people give for compiling the Linux kernel for themselves is because it's fun. Okay, now I wouldn't go so far as to say that it's fun. When I think of a fun activity, I think of something that's like carefree, okay? And compiling the kernel is not carefree. You have to follow the instructions carefully. You have to go through, make sure all the software and hardware requirements are met and things like that, okay? So it's not something to undertake casually, but it is a learning experience, and learning can be fun, so, compiling the kernel can be fun. I guess you can conclude that if you want. But it's not something to undertake with like I said, it's not some carefree activity to undertake on a whim. All right, so what we're going to do now is we're going to move out to the Linux screen and talk about the steps that we're going to undertake to compile the kernel for ourselves, and then I'll point you to some resources where you can learn more about compiling the Linux kernel. All right, well, the very first thing that you have to do if you're going to compile the Linux kernel from source code is you have to actually obtain the source code for the Linux kernel. Now, the source code for the kernel can be had in any number of ways. The most common place to get a copy of the kernel source code is from kernel.org. Okay, if you go to kernel.org, you can download the latest copy of the Linux kernel. There's all sorts of mirror sites, though, all over the internet that have copies of it. If you just search for Linux kernel in Google, you'll probably find 10 different ones. Okay, so what we're going to do is you take that source code and then you put it in some particular directory on your machine. Now, you can either put it up in the user source directory, which is where the real Linux kernel source code lives. The functioning source code for your machine would live there in one particular subdirectory, and you can just create another subdirectory for your new kernel source code. Okay, so this directory was already here. Okay, and that's the version of the kernel that I'm running on my Linux, on my Nugget SUSE box here. Okay, then what I did was I created this directory 2.6.12 because that's the version of the kernel that I just downloaded the source code for. Okay, so what I'm going to do is go into that directory, Linux-2.6.12. Okay, we're going to go down there, and in there is a tar file. And I put this tar file there. So I got this tar.gz file off the internet at kernel.org. I downloaded it to my system. Then I created this Linux 2.6.12 subdirectory from user source, and I put the tar.gz file into that subdirectory. Then what I did was I took that tar.gz file and I said tar xvzf, which extracts all the files, uncompresses it, and so on. And it does all that for linux.2.6.12.tar.gz, and then I would hit enter. Okay, I've already actually done this step, which is why I'm not hitting enter right now. When you hit enter, what's going to happen is this subdirectory is going to get created. So the linux-2.6.12 subdirectory of user source linux-2.6.12. And all of the files and directories that are part of this tar file are then put into that subdirectory. Okay, so like I said, I've already created that, I've already executed that tar command, so let's just go down into the Linux 2.6.12 subdirectory, and you can see the kinds of things that are in the tar file. There's a kernel subdirectory, a lib subdirectory, there's various README files, and so on. Okay? So this is the very first step that you have to do. You have to get the kernel source code, and then you have to unpack the kernel source code on your machine. All right, so once you have your source code unpacked in the particular directory that you've chosen, then what you need to do is you need to make sure that you have the required software in place to do the compilation. Now, the required software changes from one kernel version to another, all right? And you can learn what the required software is by doing some sort of an internet search. What I did is I went to Google and I typed compiling the Linux kernel software requirements, and I found this white paper, and in this white paper was this table. Okay, and this table lists all the different software packages that you need to have, what the minimum version you need to have of each software package, and also it gives you the command so that you can look and see which version of the software package you currently have on your system, if you have it at all. So you need to go through for each of these pieces of software, type this command, look at the version that comes up, and see if the version that comes up is greater than or equal to the minimum version. If it is, then you're all set. If the version is not up to date, or the piece of software is just not on your system at all, then what you need to do is you need to install that piece of software or update that piece of software so that all of this software is up to date to do the kernel compilation. All right. Also, what you can search for is hardware requirements. So there's a hardware recommendations usually for compiling a Linux kernel. Like, you should have a processor of this speed, you should have this much main memory, you should have this much free disk space, and things like that. And you should make sure all of those things are met. Sometimes you can get away with a slower processor or a little less main memory, but then the compilation will take longer than typical. Okay, and you just need to decide, how important it is to you. Do you really want this new kernel on your older system, and so on. So that's the second step. So once you've got all your source code unpacked, then you need to make sure that software requirements and hardware recommendations are met. Okay, so once we've met all the software and hardware requirements and we've got our kernel source code all unpacked and ready to go, now it's time to start doing some real work. And the command that we're going to use repeatedly is the make command. So make is the command that we're going to use to do the configuration of the kernel, to do the compilation of the kernel, and so on. Now, earlier I said that the GNU C compiler is what we use to compile the kernel. That's why the version of the GNU C compiler had to be up to date. Well, that's true. The GNU C compiler does the compilation, but we don't actually type GCC at the command line. We're going to use this utility called make, and make will in turn call the GCC utility for us to do the compilation. Now, there's a bunch of different arguments or targets for the make program, and you can see all the different targets by typing make help. And I'm going to pipe that through more because the output's longer than one page, and I want to see some stuff right up here at the top. So there's basically classifications of the different targets that you can give to make. The first two are cleaning targets. We're going to use make mr proper here. Make mr proper will go through the source tree and get rid of various temporary files and things that should be cleaned up before we do a compilation. Once we clean everything up, then we're going to do a configuration step, and there's all sorts of different configuration steps that we can do. Make xconfig will use the X Windows interface so you can point and click at various things. We'll use make menu config. make menu config will have everything that xconfig has, but it will just have it in a little different format. We'll have to scroll through some screens as opposed to pointing and clicking. Make old config is worth a mention. Make old config will allow you to configure your new kernel just like some old kernel that you've already configured and compiled from scratch. So say you've done a Linux kernel compilation in the past and you've configured it exactly how you want. Well, then there will be a .config file in the source tree of the old kernel. You can copy that .config file over to your new kernel source tree. So for us, it would be the Linux 2.6.12 directory here. Copy that .config file into this directory, and then you would type make old config to use all of those configuration settings for your new kernel. Now, this will only work if the versions of the kernel that you're compiling now, like 2.6.12, and the one that you're stealing the .config file from, if those kernel versions are not that vastly different, then things will probably work okay. But if your old configuration file, the .config file, was from like a 1.6 Linux kernel, and you're going to try to compile a 2.6 kernel with those configuration settings, you know, good luck. It's just not going to work. The versions are too different, the options are too different, and you're just expecting too much to occur there. But if you're doing it from a 2.6.3 kernel or a 2.4 point something kernel, then using old config will probably work. But this is only if you want to replicate the configuration of some old system that you've compiled. Okay, as we go down here, you can see things like make modules install. We'll use that to install modules on our system. Then there'll be things like make install, and we're going to use that to actually install the kernel on our system, and we'll go through all of these steps one after the other. Okay, now let's look here in this directory before we actually execute the make command. There's a file in here called makefile. This is kind of like the configuration file for the make program. It tells it what to do for each one of those different targets. Okay, and this is a really long file. It's somewhat complicated. I don't want to go through it and explain it too carefully, but there is something in there that I do want to show you how to set. And we'll open that up in the editor here. And namely, I want you to set this extra version flag. All right, so initially this is empty, and I've already set it to be Perry. This is just a way for you to distinguish between different kernels, okay? Obviously, the 2.6.12, the 2.6.12 is a version number, and that distinguishes it from other kernel version numbers on your system. But perhaps you're going to take this 2.6.12 kernel and you're going to try to customize it in a few different ways. Maybe one way will be like a very ultra streamlined kernel. Maybe one way will be like a large monolithic kernel, you know, whatever. Okay, and then you can distinguish which one's which with this extra version flag. So you could put in here, you know, big monolithic. And then you could put in here ultra streamlined. And then when you go to compile the kernel, the name will be 2.6.12 ultra streamlined or 2.6.12 monolithic. Okay, and that just gives you a way to distinguish these, you know, in human readable form. Okay, something to stir something in your memory so you can keep everything straight. Okay, so what we're going to do is here, exit out of the editor there and save your changes, and now the make file has that extra version in there. And the first thing that we're going to do with the make program is to do that make mrproper command. Now, make mrproper is going through the source tree and it's cleaning up all these temporary files and various things. If I had done compilations in this directory before, it's going to say I've cleaned up the scripts directory, I've deleted these temp files, whatever. And it's going to say different things depending on you know, what's left over in your directory. If you're doing a compilation for the first time in this directory, then you type make mrproper and probably nothing will come up and you'll just get a command prompt back. But that tells you that, okay, it's all cleaned and ready to go. All right, once we've done make mrproper, now what we're going to do is do the actual configuration step. I'm going to choose to do make menu config. You could also choose here make xconfig. To run the make xconfig package, you need to have the X Windows system on your computer. You also need to have the Qt packages, it's called. So you can try to run make xconfig, and if you don't have the Qt packages installed, it will fail and say, sorry, you need the Qt package, blah blah blah, on your system. Go out and get the RPM and install it if you want to do make xconfig. To do make menu config, you need the ncurses packages on your system. So ncurses, the ncurses packages and ncurses hyphen development. You'll need both of those. And the same thing goes for make menu config. If you typed it and you did not have one of the correct packages in place, it would fail and it would say, sorry, you don't have the ncurses development package in place. Okay? So make sure those packages are met. They're kind of like hidden software requirements to do the kernel compilation. I'm going to hit enter here. It's going to go through a few things, and it's going to bring up the menu config screen for us to configure our kernel. This is the part of the process that takes all the time. This is where all the tedious various steps come in. Okay? And here, what I can do is I can select different menus by scrolling up and down, and I can also use these letters that are in the front as sort of shortcuts to get to some particular menu screen. Okay, so let's go down to loadable module support, for instance. If I hit enter there, then you can see there's a star there that says enable loadable module support. If I hit N there while that's highlighted, that will take away loadable module support. So now I have what, in sense, a monolithic kernel because I don't have loadable modules. If I hit Y there, then I'm enabling loadable module support, and I also have these sort of subcategories lit up here as well. So I can go through and enable or disable those as I see fit. All right. If I hit escape, I go back to the top level menu, and then I can go down and talk about power management. I can set things for that. I can set file systems and device drivers. So here you can see that the second extended file system support is built into the kernel. Okay, that's what the star means, that it's built in. If there's an M there, okay, like there, for the ext3 file system, that means the ext3 file system is available as a module. Okay, now what this means is that if I go down to ext3 and I hit Y, then that's going to be a star, and now the ext3 file system is going to be compiled into my kernel, compiled into the base kernel. All right, if all I ever want to use on my system is ext3, for instance, I could go through and get rid of ext2, and I could get rid of riser and all that stuff, and just say no to those. Just put an N there, and then those will go away, and I will only have exactly what I want. So that's what we're talking about when we talk about streamlining. If you know specifically for your system that you're only going to use this, or you're never going to use this, then you can get rid of certain things and customize this as you see fit. All right, I'm going to put ext3 back to being a module, okay, and set it up that way. All right, so this is the kinds of things that you can do in the make menu config screen. I'm not going to go through all of the different possibilities here. There's lots of different menus and sub-menus and sub-options to all of these things. That would take 3 hours to go through all those for you, and you'd be long asleep by then, okay? Instead, what I'm going to do is I've just showed you how menu config works, basically, and I'll point you to some resources where you can learn more about customizing things and give you some good pointers on what you can sort of focus on if you want to customize your kernel in some particular way. So once you're done going through the configuration process, then what you do is you exit out of the configuration utility and you save your changes. And then what happens is there's a .config file that is created in your source code directory. All right. Now, the .config file there just represents all the settings that you made in the utility, whether you used xconfig or menu config. It just wrote the .config file to save all those changes. Now, there's a couple things that could happen during the configuration process. One is that you could streamline it too much. Say you're trying to streamline a kernel and you just start getting rid of this, get rid of this, take this out of the kernel, take that out of the kernel. Well, it could be that you took out too much to have a functioning system. maybe at the next step when we go to compile the kernel, it will actually compile successfully, but you won't be able to boot into it, or you can boot into it, but you won't have the use of some device that you want, okay? If that's the case, then you're going to have to go back and reconfigure the kernel and go through that whole step again, menu configure, xconfig, whichever one you chose. Okay, you'll have to do that whole process again if you pare it out too much. If you have extra stuff in the kernel, you say like, well, I want this in the kernel and that in the kernel and this in the kernel. If you pick so much stuff to put into the kernel, then the kernel can become, you know, the slow monolithic kind of kernel. And the happy medium there is that if you're not sure, then, you know, enable loadable module support and just leave the thing available as a module. If you're not sure whether you need some particular functionality, just say, okay, well, I'll leave that as, you know, I can plug that in as a module at some later date if I need it. Okay, so that's kind of the happy medium. But like if you're looking for that ultra streamlined kernel, you might get rid of too much in that configuration step and you'll have to redo it all. All right, so once that configuration file then has been written and the config step is over, now it's time to actually just compile the kernel. And there we can just type the make command all by itself. We don't need any special targets or arguments, and the make command will then go through and do a whole bunch of steps for us. It will go ahead and do dependency checks and make sure all the code dependencies are met. It will go through and make sure it will create a BZ image, okay, which will create a binary image of the kernel so that you can boot up. It'll install modules and do things like that. Okay, so I'm just going to hit the make command here. It's going to take a while to execute, so I'm just going to pause the video and then we'll come back when it's all finished. Okay, so now we've finished compiling the kernel. We're back to the command line here. And remember that all we did there to compile that was type the make command. Going back to the make help screen, it will tell you down at the bottom, executing make or make all will build all the targets marked with a star. So we just did a few things here. Basically what we did was we did a make modules and we did a make BZ image, so now we have the compressed kernel image. Okay, now let's quit out of there and let's look in the architecture subdirectory i386, which is the architecture I have on my machine. And if we go in there, inside of there will be a boot directory, and in the boot directory will be the BZ image. Okay, so this is the image now, the kernel image that we've created from the compilation step. So instead of just typing make there, where I could have typed make modules, make BZ image, and so on, instead I just typed make and I executed all those things at once. All right, so now that we're finished with that, what we're going to do is we're going to now take the next steps, which have to do with installing the modules and then also installing the system so that we can boot it. All right, so let's go back to this other window here, and now what I'm going to do is I'm going to say make modules underscore install. Okay, and modules underscore install is going to install the modules in the /live/modules directory. This is one where you have to be the root user to execute this command. You can't be the regular user and execute this command. All right, so this is going to go on. I'm going to pause the video and come back when this is finished. All right, well now make modules install has been completed. Now we say make install. Make install will actually automatically copy the kernel to /boot, and then it's going to create all the other files that it needs. And it's also going to modify the bootloader to boot the new kernel by default. So we'll look in the bootloader and make sure that that it's set up the way that we want it to be set up. And I'll show you how to change which image gets booted by default when this is finished. Now everything's been compiled, and the very last step that you might have to take is to modify your bootloader so that you specify your new kernel in the bootloader, and then when you reboot your system, you'll have your choice of which kernel to boot into. All right. The thing here is that there's different, this is where different versions of Linux deviate in the way they handle things. And also there's two bootloaders out there. There's the Grub bootloader and the Lilo bootloader. The Lilo bootloader is kind of going by the wayside, but if you are using the Lilo bootloader, then look in etsy lilo.conf for the bootloader configuration file and specify your new kernel in there. The other thing is, if you're using grub on Red Hat Linux, that's in etcgrub.conf. But every other version of Linux that uses grub does it like this. They put it in the boot directory, and in the boot directory is a file or a subdirectory called grub, and then in the grub subdirectory is a file called menu.lst. And this is the configuration for grub that you should edit that file to specify the new kernel that you just created. Okay? Specifically, it's this VM Linux 2.6.12 that's in the /boot directory, right? With the Perry on the end. That's the kernel image that I've created. Okay, and you can see there's the system map 2.6.12 Perry. That's also been put into the boot directory with all these make commands that we've been doing. All right, now SUSE Linux differs from other versions of Linux in that you can't edit menu.lst directly. They want you to go through the YAST system tool to do that. So you have to bring up that graphical system administration tool to change the bootloader configuration steps here. So you can choose whether, which kernel you want to boot by default, and you can specify all sorts of things through that tool. But that's a small potatoes compared to what we've already done. And that's pretty much it. That's all you have to do for customizing and compiling your own kernel. And what I want to do now is just point you to some resources so you can get more information about every step of this process, from where to get source code right up to how to edit grub and Lilo specifically for your particular Linux distribution. So I did a search for compiling a custom Linux kernel in Google, and there's one here on the Bitbender forums, and this is probably the most authoritative, very detailed reference for compiling a custom kernel for yourself. And you can see here just from the steps, it talks about the source tree, configuring the kernel, building the kernel, installing the kernel, editing the bootloader configuration. It goes through all the different permutations for that. It has an updates here for the 2.6 kernel, which is the most recent kernel that's out there, and you should just go through this. If you're going to compile a Linux kernel, follow the directions I've given you, and also use this as a reference to get specifics for any particular variant that you might want to do that's different from the way that I did it. Well, it's time to wrap up our nugget on compiling the Linux kernel. First, we started talking about what it means to compile the Linux kernel. We talked about how Linux was a modular kernel, and you get to decide when you customize and compile your own Linux kernel what goes in the base kernel and what's available as modules that can be added in later. Then we talked about why you might want to compile the Linux kernel for yourself, for everything from kernel development to adding a brand spanking new piece of hardware to customizing it so that it's very ultra efficient and streamlined for a particular high performance system. And then we mentioned how to compile the Linux kernel. I walked you through the steps, how to use the make program, how to make sure that your software and hardware requirements were met, and we walked through exactly how to compile the Linux kernel. And finally, I pointed you to a good resource, the best resource I know on the internet, for more detailed information about how to compile the Linux kernel. Well, I hope you found this nugget informative, and thanks for watching.